Okay, this is example 6 from 7.3. Lots of examples, I know, but like most algebraic techniques, it's really, really important that you practice these as much as possible because that is the only way to get more proficient at them. So we are going to look at solving for the absolute value of a positive and solving for the absolute value of a negative. If the insert expression x minus 10 is positive, then the absolute value does nothing. So it's x minus 10 equals x squared minus 10x. If the absolute value is on a negative number, it multiplies the inner expression by a negative. We're going to distribute that, and I get negative x plus 10 is equal to x squared minus 10x. Now, it's worth mentioning that at this point, neither of those cases, the positive case and the negative case, is an absolute value anymore. They're both really chapter 4 questions. They're solving a quadratic, although within that absolute value context. So in order to solve this, what I'm going to do is I'm going to get one side equal to 0 because it's quadratic. So I'm going to subtract x. I'm going to add 10, subtract x and add 10. And I get that 0 is equal to x squared minus 11x plus 10. And then I can factor that. So 0 is equal to x minus 10 times x minus 1, which tells me that either x minus 10 is equal to 0, which yields x is equal to 10, x minus 1 is equal to 0, which yields that x is equal to 1. Now, at some point, you have to make sure that you verify these. I'm going to verify them right now, so we're going to plug them into the original expression. So we're going to check x equals 10 and x equals 1 in that original above, and what we would have in this case is the absolute value of 10 minus 10 is equal to 10 squared minus 10 times 10. Well, this is the absolute value of 0, and the right-hand side is 100 minus 100. So I'm left with 0 is equal to 0. So that is one of our solutions. If x is equal to 1, we have the absolute value of 1 minus 10 is equal to 1 squared minus 10 times 1. This is the absolute value of negative 9 is equal to negative 9. And that's a problem, because this tells me that 9 is equal to negative 9. That's not okay, which means that x equals 1 is not a solution. So the positive case only gave us x equals 10 as our solution, which means we need to kind of switch gears and finish our negative case. Now, it's worth mentioning that if the negative case yields x equals 1, that is not a solution. The verification is done on the original equation. So if you get the same answer kind of on both cases, you don't have to check it twice. If you've already checked it, you do not need to check it again. So what we're going to do is we are going to solve this equation very, very similarly. I'm going to add x on both sides. I'm going to subtract 10 on both sides. And I get that 0 is equal to x squared minus 9x minus 10. So 0 is equal to x minus 10 times x plus 1. X minus 10 is equal to 0. That gives me that x is equal to 10. X plus 1 is equal to 0. That gives me that x is equal to negative 1. Now, similar to what I talked about before, I don't have to re-verify x equals 10. I know that's the solution, but I'm not going to list it twice. The reason that x equals 10 is showing up in both of these cases is when x is equal to 10, we get the absolute value of 0. So it really is going to be one of those solutions that's kind of, you could include it in both, but we're only going to write it out once when we summarize our answers. So we already know this is right. I'm not going to verify it again, but we do have to verify negative 1. So we are checking if the absolute value of negative 1 minus 10 is equal to negative 1 squared minus 10 times negative 1. This gives me the absolute value of negative 11. Over here, I have 1 plus 10. So this gives me that 11 is equal to 11. So that is a solution. Now, like I mentioned in the previous examples, it's nice if you summarize your answer. So just on the bottom or somewhere on the page, I would say, okay, x can be equal to negative 1 or positive 10. And those are my only two solutions. I would encourage you to graph the equation above. Remember that y1 would be the left-hand side, y2 would be the right-hand side, and anywhere those functions intersect is the solution. All right, I'm just going to put up the homework page for 7.3 here. Keep in mind that, you don't have to hand in your whole homework. We're going to check a specific question, but you are going to have a nice long chunk of time with that Easter break. I would recommend finishing it this week so you don't have to do any math over Easter break. All right, good luck. And remember to email if you're having any trouble or need some more help.